Sleep School from the H Behaviors Lab.
Welcome! Throughout this presentation, we will cover all the topics our research spans.
Throughout the summer, our team has been working on a few different projects, which will be outlined for you in this presentation. We will be discussing participatory research, phenotyping, the iron conundrum, the biobank, brain MRI, and finally consent forms. We will discuss how all these topics have been woven together to complete the picture that is our research. Let's begin with who we are. We are a team of people from many different areas of research and community members, professors, researchers, doctors, med school, university, and high school students, as well as Indigenous community members, all putting our heads together to collaborate on ways to give back to the community. This collaboration allows us to improve our research techniques, but also return back to the community more valuable studies. Now you have a sense of who we are, we want to share what we do in our lab, the H Behaviors Lab. So what does the H stand for? The H stands for hyper and hypo behaviors, which mean increase or decrease behaviors. We are interested in behaviors that are above or below average activity. For example, restless leg syndrome would be considered a hyperactive behavior because the legs are moving more than they should.
How does this connect to our work with ADHD and restlessness? Sleep can have multiple effects on our daily lives. For example, if you get a bad sleep because of your restless leg syndrome, you may have certain behaviors during the day, such as fidgeting to keep yourself awake, that resemble ADHD-like behaviors. This lack of sleep is causing kids to be improperly diagnosed and treated with drugs when they don't need to be. Throughout our work, we will be focusing on how iron plays a role in this, environmental aspects we need to be sensitive about, and how developing a sense of community is important for improving the lives of others and for well-rounded research.
Participatory research is a major theme that we try to incorporate in our work. Dr. Lori Cox, who works at the Eastern Door Center with the Indigenous Elsipogtog people, has shown us how research can be done with respect while being as inclusive as possible. This is called participatory research, and we try to incorporate that frame of mind into what we do. Two-eyed seeing is a concept developed by Mi'kmaq elders and Dr. Lori Cox on how to approach participatory research. One eye looks through a scientific lens, and the other looks through a traditional indigenous lens. Seeing with both eyes gives greater perspective. By treating our research participants as equals and understanding the situation from their point of view, rather than patronizing them, we can develop better methods of treatment and help improve the overall health of the community. This means that we have to be understanding of their sensitivities. We have to recognize that they come from different cultures and traditions and may have different beliefs. And most importantly, we have to work with and for them.
Good communication between researchers and participants is essential to establish this relationship. Although consent forms are often the first form of communication shared between them, their current design makes it so participants rarely have the time or patience to read through them. With that in mind, our goal with this project was to redesign consent forms to be more visually appealing, less intimidating, and easier to read while keeping all essential information intact. Together with students at Emily Carr University, we have created a completely new consent form concept. We hope that this helps people better understand their role when participating in studies, as well as better inform them before they give their consent or assent. As we walk you through our project, we will show you excerpts of our new and improved consent forms. Stay tuned until the end of the presentation to see our process in detail and hear our thought process in making these changes.
Restless leg syndrome, or RLS in children, can lead to chronic insomnia, which then can cause behaviors to be presented as attention deficit hyperactivity disorder, or ADHD. This results in children being prescribed drugs to treat these behaviors relating to ADHD and RLS that are unnecessary. Iron deficiency may be the main cause of this problem, and iron supplementation can be used to treat neurobehavioral conditions instead of prescribing medication. First, we'll be talking about how we like to look at these H behaviors. This is called phenotyping. Then, if iron plays a role in presenting these behaviors, we need to find ways to dig deeper into where we find iron and how to quantify it in the body and brain. This is our work with the biobank and MRI team. The phenotyping team consists of Andrea, Harvey, Marina, Sabrina, and our designer, Jihan. So what is phenotyping? Phenotyping is observing a behavior or trait as a result of genetics and/or environmental determinants. Restlessness can affect sleep and daytime behaviors, and this may be presented as ADHD. We are trying to understand the correlation between vigilance, fidgeting, and tension, and in order to understand them, we need to observe these behaviors and their relation to ADHD and RLS. Vigilance is how alert and aroused an individual is. So how do we see if someone is affected by ADHD using vigilance? We can investigate this through machine learning, a sleep smart study, and Ethica, an app.
Dr. Leonid Segal, professor of computer science from UBC, works in the field of machine learning and discussed how we can better anonymize patient data through direct and indirect methods. With phenotyping, it is important to measure the facial expressions and body language of the study participants, which means we cannot use the direct method of blurring out their face or body like usual. One solution Dr. Segal presented was to use an indirect method, where a computer program is used to convert the patient into a stick figure representation. This would allow researchers to anonymize patient data while still gathering the necessary information about the patient's body movement.
One of the primary ways phenotyping is included in our work is through the Sleep Smart study. The purpose of this study is to collect data about the participant with 3 devices: the Sleep Smart mattress, Connect video system, and electromyography. This data will then be used to further improve these devices and help improve clinical tests like SIT and SCIT, which are used to help diagnose sleep disorders in children. The participant will be asked to come in and either sit on a chair or lie down and sleep on the mattress, while the devices will then collect data in 3 ways, thus completing the SIT and SCIT test. The Sleep Smart mattress, which is a sheet fitted over a mattress pad with sensors, collects information about body temperature, movement, and position as the person is lying on it. The Connect is a video recording device that collects data about visual movement pattern. It allows the researchers to analyze how the participant moves while they are sleeping as well as sitting. Electromyography, which involves electropads placed on the lower legs, collects data about muscle movement. This allows researchers to look at the electrical activity of muscles when the participant moves.
We recently were approached to try out a new app to enable us to collect our data efficiently. Using smartphones is a more convenient and efficient way to collect data from youth. We are using Ethica, which is an app that allows us to monitor patients' sleep by tracking when the cell phone screen is on or even off, as well as including photos of the individual in the morning and at night to compare vigilance at those times. Also, we can implement surveys to rate perceived vigilance and other parameters. All this data collected by this app will help us to understand better vigilance and youth. Now that we have looked at the behaviors, we want to investigate what is causing these behaviors. We think that iron plays an important role as it is one of the greatest nutritional problems in the world.
Here is an example of a reformulated page from the Sleep Smart study consent form. Oftentimes, participants may feel intimidated by the lengthy and heavy text of consent forms. In order to decrease these feelings and improve communication between researchers and participants, we redesigned these consent forms with the goal of making them easier to read and universally accessible. As seen here, we restructured the layout to include pictures of the devices, simplified the wording, and used more whitespace and sectioning to make the consent form easy to understand.
So where does iron fit into this story? Well, we should begin with how iron functions in the body. Firstly, iron is a key component in hemoglobin, which transports oxygen from the lungs throughout the body. Iron is also an important cofactor that facilitates enzymatic activity. Some of these enzymes that require iron as a cofactor are involved in oxidative phosphorylation, a pathway which supplies cells and the body with energy. Now, iron deficiency is the #1 nutritional-related health disorder in the world, according to the World Health Organization. Because of the importance of iron, a deficiency of iron can lead to long-term developmental consequences. These include an increased risk of significant hearing loss and a decrease in physical, cognitive, and metabolic performance.
Anemia is a decrease in healthy red blood cells, or hemoglobin, that can be caused by lowered production of these cells due to iron deficiency. We mentioned in the previous slide that iron is a key component of hemoglobin.
The map here from WHO shows the prevalence of anemia in women of reproductive age around the world, giving insight to the global impact that iron deficiency has. Although North America has a lower prevalence of anemia compared to other countries, even 10% of this specific population is a lot of people.
This next map shows the prevalence of anemia in infants and children aged 6 to 59 months. We notice that generally, the prevalence of anemia in young children is greater than women of reproductive age, and that the pattern of prevalence is consistent with the previous map. This shows a possible connection between parents with iron deficiency and iron deficient children that may be the result of anemia being familial.
Recent scoping reviews reveal that iron deficiency may also contribute to neurodevelopmental disorders such as RLS and ADHD. They found a general positive correlation between the two, and higher-level treatment studies show that iron supplements may have a positive effect on patients with RLS and ADHD. From the studies reviewed, iron deficiency was mainly determined by measuring the amount of ferritin in the blood. Collecting blood samples for researchers and clinicians is just one of the many functions of the biobank.
The biobank team consists of Chris, Michelle, Michaela H., Michaela W., and our designer, Augusta. Scientists are always doing research to improve the quality of life for millions of people by finding effective treatments for different conditions. To aid them in their research, the BC Children's Hospital has a biobank, which is a collection of patient samples and de-identified information donated by members of the public who have received medical attention from the hospital. This collection of health information and biological samples, such as blood, makes it possible for scientists to improve and develop new treatments and therapies for patients. To help us better our understanding regarding the importance of iron, with the help of the biobank, scientists are able to conduct further research using a large range of samples. The aspect most significant to our studies done in the H Behaviors Lab is that data from the biobank can be used to compare peripheral iron levels in the blood samples to iron levels in the brain, which allows us to further our research in relation to the iron conundrum.
Biobanking can also help with the study of epigenetics, which are persistent and heritable alterations in genomic information that do not involve the alteration of DNA, for example, methylation and histone regulation. This is via means by which the genome interacts with environment, including stress, nutrition, and toxins. With the samples collected by the biobank, researchers will have the opportunity to do epigenetic profiling. This will provide insight on certain populations, for example, developmental disorders, in regards to common epigenetic changes in DNA, which may provide a direction for treatment and preventative measures. Nutrition plays a large role in epigenetics as well. Diet during the developmental stages of life has lasting effects and contributes to gene function as well as metabolic health in child and adulthood. For example, studies have been done regarding B vitamins, which are important nutrients during pregnancy. Vitamin B9, otherwise known as folate, is present in the food we eat. It is essential to many biological processes, such as the production of red and white blood cells and DNA. In Canada, the fortification of folic acid in foods is government mandated as of 1998. It is used to prevent neural tube defects and folate deficiency. This is found to be very successful as the folate status of Canadians is high. Pregnant women are recommended to take 0.4 milligrams of folic acid per day, but supplements can result in an intake of about 1 milligram per day. In addition, it is estimated that 1 in 20 adults are deficient in vitamin B12. The resulting imbalance in folate and vitamin B12, specifically in pregnant women, affects the metabolic health of their offspring. A mouse model of folate and vitamin B12 imbalance during pregnancy found that those supplemented with folate but deficient in B12 had higher levels of gonadal fat, increased glucose intolerance, smaller pancreas size, and lighter beta cell mass, which produces insulin, when compared to the control group. It is also important to note that there is a sex-specific difference found in this study, such that females have greater adiposity and disturbances in glucose homeostasis, whereas there were no adverse effects observed in the males. This is an example of how the mother's diet can affect how genes function in their offspring, and it's just a small glimpse into the studies being done within the epigenetics field. As aforementioned, the study of epigenetics involves changes in environment, such as diet, but not DNA. Dr. Lori Cox spoke to us about traditional indigenous diets and how their bodies have been geared to process meats and proteins as opposed to the Western diet. However, the indigenous diet has shifted towards a more Western style due to carbohydrates being cheaper and more readily available. As a result, their bodies are not used to processing the foods involved with this change, which is prevalent in the observation of some communities having issues with both malnourishment and obesity. The idea of epigenetics creates a more open and contextual framework for the indigenous community. It does not place the blame on the people, but rather takes into account external factors. Here is a page from the reformulated BC Children's Hospital Biobank Ascend form. In order to facilitate data collection and improve communication between researchers and participants, we investigated the forms with the goal to make them easier to understand and more accessible, by changing aspects such as layout and simplifying text. As mentioned, we are conducting research with the biobank to observe peripheral iron levels in the blood, which can then be compared to levels in the brain, measured using brain MRI.
The Brain Iron MRI team consists of Dylan and Kevin and our designer Canuck.
Before we look to how iron in the brain is important, we want to stress again that iron deficiency is very common and universal. So let's begin with a brief look at several iron-rich areas in the brain. These include the dorsal striatum, which facilitates thinking about moving, the substantia nigra, which plays an important role in eye movement and motor planning, and the red nucleus, which is involved with motor coordination. A common theme is apparent, in that these brain structures that are rich in iron have a functional relationship with movement. Then we observe a possible direct relationship between iron deficiency or defect in the brain and restlessness. This can then also be connected with RLS and ADHD.
It is clear that iron plays an important role in controlling and regulating movement. It is also required to create neurotransmitters and myelin, which are essential for overall brain function. This observation is one way that we can visualize iron deficiency in the brain. Areas that have lower myelin levels than expected are often iron deficient, and the lack of iron is suspected to be the cause of motor, cognitive, and hearing impairment.
Magnetic susceptibility is a measure of the extent of which a material is magnetized when placed in an external magnetic field. A magnetic field is generated by MRI, which is just a giant magnet, and the tissues and substances of the patient lying in the MRI machine push or pull on the local magnetic field based on their different properties, and give off different images in the scan as a result. Magnitude of the distortions are also affected by the amount of material that is present. These distortions in the field can be detected by certain MRI sequences, notably T2 star weighing. An example of what it can detect is iron deposition.
Although T2 star is the current standard, there are new techniques constantly being developed. One example is quantitative susceptibility mapping, or QSM, which takes phase information, which is usually discarded from most images, to form the image that we are looking at. This is yet another way that we can visualize iron in the brain. Although MRI is a completely safe and painless procedure, there are still many challenges associated with getting a scan. The scanner makes loud knocking noises, which can be frightening as it is running, and it is a fairly enclosed space, which can cause claustrophobia. For children specifically, sitting still during the scan is also a challenge. One way we can get around most of these is to have children go through a simulation scan where they run through the procedure and prepare themselves for the real event. For all participants, they can also listen to music and utilize anxiety-reducing techniques to help overcome some of these challenges. Here's just one page comparing the before and after of the MRI consent forms. As you can see, we have changed this daunting list of large words and condensed it to just a few key features with pictograms to help aid understanding.
As aforementioned, patient-researcher communication is vital to all aspects of research. We use consent forms to help convey messages, including difficulties in MRI scanning and solutions. This leads us to the questions, what should be addressed, and how should we present these ideas? These questions were answered with the help of our design team.
Hello, we are the designers working on the consent assent form redesigns for biobank, phenotype, and MRI. Our names are Augusta Lutinsky, Jian Cho, and Kanak Jaitley. As mentioned previously, this project aimed to redesign existing assent and consent forms to make them more visually appealing and easier to read. Our main goals with this project were to increase the interest and willingness of people to participate in research, as well as to improve their understanding of research in general. This is one example of a consent form that we redesigned. The Vsss team first rewrote the form in plain language and added formatting elements like bullet points and bolding to make it easier to read. We then worked with them to visualize the forms by adding design elements like sectioning and pictograms to make them more visually appealing. As part of our process, we each created storyboards to help us put ourselves in the shoes of the participant to try and understand the role that new and improved consent forms can play in research. Here, I imagined a participant with a broken leg coming into the hospital to go over a consent form. He realizes the elevator is broken and cannot take the stairs, so he decides to wait in the lobby and hopes the research assistant will come find him. 20 minutes pass, and he starts to feel agitated, wondering why he bothered to come at all at this point. Eventually, the research assistant realizes something is wrong and comes to get him. By this point, the participant is beginning to feel restless, and when he sees the long pages of text in the consent form he's about to read, he decides that this whole process isn't worth it and withdraws from participation.
This second storyboard, you can see a participant who is playing with their friends but needs to leave early to go participate in a study. His day is already disrupted and he begins to feel uneasy. After they arrive, the participant and the parent meet the research assistant and they receive the consent form. The parent and research assistant encourage the participant to read the form and ask if there are any questions, but the participant is feeling impatient and decides to take the form home instead. After this event, 10 days pass by and the consent form gets forgotten. The parent receives a reminder of the study from the research assistant and asks where the form is so they can finally read it together. However, when they find the form, a page was missing and they don't want to go through the process all over again. The participant eventually gives up and just asks his parent, "Can I just not do it?"
Let's look at the third example. We have a participant who is very excited to be a part of the MRI study, but is anxious as she suffers from claustrophobia. The participant has lots of questions while waiting in the room, creating fear and anxiety. When the technician asks her whether she is ready for the study, she is stressed and anxious and starts asking the technician lots of questions. The technician brings in the consent forms and takes her through each section clearly. She herself feels a bit better by understanding the procedure, having visuals which she connects to, and understanding that she can stop the study when she wants. Thus, having a proper laid out, less dense form can make the participant more relieved to be a part of the study. What we took away from this experience was how big an impact a good consent form can make. We decided we wanted to make the forms more accessible and convenient. We wanted to decrease the frustration and anxiety associated with the forms and make the consenting process more engaging. To do this, we used many design elements while working on the study, ranging from having adequate white space around paragraphs to breaking information down and changing the flow of sections. Each element used added its own touch to the consent form.
In this example, you can see how the original form was improved with the use of white space. The eyes gravitate towards certain areas of information, and it also makes the text feel less weighty and dense. This small change can make the information on the form more coherent and increase the reader's interest in its content.
Here, you can see that the use of pictograms on the right can help the users understand the procedures more clearly, aid their understanding visually, and simply makes the form more interesting and to look at when compared to the text-only version.
Lastly, but not the least, the sectioning of information. Having a proper flow which is intuitive to the person reading the form is an important element. We segregated sections, introduced bullet points, and bolded the text to bring important sections to the forefront. Gray boxes were used as a design element to highlight important information.
Using some of these design elements we just spoke of, the teams are reworking the original consent forms and considering how to make them more engaging and effective for the user. Let us show you one example page from each of the biobank, phenotype, and MRI forms separately to show you the difference briefly. So first of all, the biobank team. In this biobank assent form, you can see the changes from the original form to the redesigned form. The goal is emphasized using color and bolding. This form is written from the participant's perspective, as if they were meeting a research assistant and asking questions like who is conducting it, why are they, and when. And information is chunked according to each section. This makes the form easy for the reader to follow, as they can assume where to look next based on the consistent layout.
Secondly, the phenotype team. In this slide, you can see the changes from the original phenotype assent form to the redesigned form. You probably noticed the difference right away even before I explain. The long body of text are positioned in different ways to keep the form interesting to look at, with lots of white space in between. Pictures were also added to help aid understanding the text.
This is the final draft of the MRI consent form. We created an invitation page to make the form feel more accessible and easy to read. We also added separate sections and grouped important information together.
Looking forward to the future, we hope to implement these visualized consent forms in other areas of research.
My name is Michaela, and I am working with the biobank team, as well as on a related project with BC Children's Hospital's Self-Injurious Behaviors Clinic. The SIB Clinic is a multidisciplinary team that assesses patients presenting with self-injurious behaviors in the context of neurodevelopmental disorders. These children present with these behaviors, and we note that some of the affecting behavioral factors include those of sleep, ADHD-like behaviors, as well as nutrition, and an overall interaction with iron metabolism. The goal is to work under the instruction of the clinic to develop a protocol with simplified explanations, following the process we have used with developing the consent forms, in order to help families understand and consent to the investigations their child will undertake, such as blood work and brain MRI. Investigations into blood work markers, iron metabolism, and brain iron imaging may help determine reasons behind the behavior of this vulnerable population and potential solutions for future treatment.
On behalf of the Vancouver Summer Sleep School, thank you for listening to our presentation. We hope to continue finding ways to overcome the barriers that are currently present regarding communication between patients and researchers. In addition, we would also like to acknowledge all the people who have shared their research with us and contributed to the H Behaviors Lab.